Your print just failed. Not because of your slicer, not because of your machine, not because of your part design, not even because of your slicer settings. It failed because there's water inside your filament. Every time that filament hits the hot end, the water flashes into steam. You get bubbles, voids, weak layers, surface defects, and almost nobody in this industry handles it the best way possible. We're here to change that. So many people either don't even know this or they don't have an effective way to fight it. So today, we're going to tell you how we dry our filament for all of our different materials. Here at Vision Miner, we've been printing Ultem and PEEK and Policarb and Nylon, PPS, you name it, every single day for the last decade. We print these materials in production volumes for aerospace, defense, and medical customers, the kinds of customers that actually test their parts before they fly them. And the single biggest thing that separates a good print from a scrap part isn't the machine. It's how you handle the filament before it even gets into the machine. So let's talk about that. Most engineering polymers are hygroscopic. That's H-Y-G-R-O. That means that they're actively pulling water out of the air. Ultem does it, PEEK does it, Nylon is famously good at it, polycarbonate, PPSU, ABS, PETG, you name it, even PLA. And here's the kicker. A peer-reviewed study on Ultem 9085 found that the filament reaches an unacceptable moisture level within 1 hour of sitting out at room temperature. 1 hour! That's not the spool that you forget about for a week. That's the spool that you took out of the bag this morning to print before lunch. In fact, our own internal testing on materials like Ultem and PEEK is that they soak moisture up in minutes. Not hours, but once that bag is open, the clock is ticking. Now, when moisture is trapped inside the filament and you push it out of a 400 Celsius hot end, the water doesn't just evaporate, it flashes into steam. Steam inside of a molten polymer means bubbles and voids, and that results in weak layer adhesion and a lot of surface defects. Sometimes you don't even know what happened until the print fails in printing. Or worse, the part fails in testing. And that is the problem we're solving today. So how do you get the water out without destroying the polymer? You think you could just bake it. Crank up the oven, evaporate the water, done. The problem is, water boils at 100 Celsius at sea level. To pull moisture out of the inside of the filament, not just from the surface, you need real heat and real time. And every minute that your polymer sits at high temperature, it's degrading. Heat breaks polymer chains down, very slowly, but it goes until you end up with a spool that snaps every 2 feet inside the loop of the machine. You just wasted 3 days of work and you can't get any prints to finish because it just keeps breaking on the path to the extruder. And that is where the vacuum comes in. When you drop the pressure inside of a sealed chamber, you drop the boiling point of water with it. If you pull a deep enough vacuum, water will boil out at room temperature, which means you can drive moisture out of the filament without cooking the polymer. And that's basically the whole game. You want to get the water out and leave the polymer intact. So here's exactly how we do it on our shop floor. Step 1. The night before or earlier in the day, you pick the spool that you're going to print with. Ultem 1010, Ultem 9085, PEEK, ABS, whatever it is. You put it into the oven. Set the temperature for whatever the manufacturer specifies. For most Ultem, that's around 120 C. For PEEK, that's 120 to 140. For Nylon, 90 is about the sweet spot, and the lower temperature materials, around 70. Even lower sometimes for some of the PLAs of the world. Just check the data sheet. Every material and every manufacturer is a little bit different, so just check with that and you'll be fine. Now, here's a pro tip that took us years to figure out. You don't just want to leave it in the oven and pull it out cold the next morning. You actually can't do that. It doesn't work. About an hour before we leave for the day, we actually turn the oven off and we pull a vacuum on the spool while it cools down overnight. Now this could be a vacuum oven or just one of our vacuum chambers that we sell at visionminer.com/dry kit. The spool actually cools down to room temperature inside the vacuum. So there's no air, there's no moisture, there's no opportunity for the polymer to start reabsorbing humidity while it's sitting in there. Because here's the thing, hot polymers absorb moisture faster than room temperature polymers. A hot spool sitting in open air is basically a sponge. In the morning, you pull it out of the chamber, walk it straight to the preheated machine, load it up, and start printing. The whole transfer from vacuum to extruder should take really 30 seconds to a minute at most. Not 5 minutes, not let me go grab a coffee first, 30 seconds to a minute. And this is all part of process discipline, and that's something we build into the machines that we sell and the tools that we create to support them. Our 22 IDEX here has a 100 Celsius actively heated chamber, so that's a huge advantage because once the filament goes in, it's going to stay dry. It's not reabsorbing moisture mid-print. There's no quality drift on a 56-hour print job. If you want a machine that'll run PEEK and Ultem and PPS and polycarbonate or ABS and Nylon, those ones, especially at full build volume because of that heated chamber, then give us a call. The warping is way better and it can actually handle huge parts, thick parts. And just give us a call, shoot us an email, we'll get you set up. And of course, we've got this exact setup at visionminer.com/drykit. Now, what you get with that is a custom vacuum chamber. This is not like the vacuum chambers you find on Amazon. We actually had this custom molded and custom designed, so it's extra large to fit those big 5, 10, 20 kilo spools. Most of the chambers you'll find online aren't actually big enough to fit those spools. We've actually had customers, this has really surprised me, but people have sent in pictures of their vacuum chambers they got off Amazon and the entire chamber was imploded. So this is stainless steel and it's very high quality and thicker, so it's not gonna do that. So go check this setup out at visionminer.com/drykit. We've got these for sale and man, it is a game changer. So let's talk about how you can tell during your print, at the beginning of the print, whether or not your filament is still wet, because sometimes you think you dried it, but it's not actually there. So there's a few things you want to do before you walk away from the machine on a long print. When you're doing that first nozzle purge on the machine, like right when you load the material, you want to watch the material. You want to watch it really closely. In extreme cases, you'll see actual steam coming off of the nozzle, coming out of the extrusion. In medium cases, there will be little bubbles forming as the polymer flows out of the nozzle. In milder cases, you'll get an occasional bubble instead of a smooth, glassy strand of molten polymer. Now, those are how you can tell that your spool, your filament, is still wet. If you purge a good foot or two of material before you start the print and it comes out perfectly smooth and beautiful, then you're pretty much good to go. If it's still bubbling at all or anything like that, back to the oven, back to the vacuum, you gotta start over. It's not worth the failed print or the low quality of the print that you'll get on most jobs, especially not with the high-end ultra polymer filaments. Now, quick aside on the differences between materials. Nylon is actually one of the easiest. Nylon will actually dry out just from sitting in a hot chamber, especially like in the 22. So if you're printing nylon tomorrow, you can just put the spool in the chamber overnight with the heater on, and by morning you'll be good to go. Ultem, however, is much trickier. You'll need to do the full oven and vacuum cycle before you print. PEEK is even tougher. It's slower to absorb moisture, but it's also slower to give the moisture up. Once it's wet, it takes even longer to dry, so you need to plan accordingly. And whatever you do, don't leave 17 spools in the oven for 2 weeks because you might use them eventually. We learned the hard way. That's how you end up ruining filament before you ever load it into your machine. The polymer degrades, it gets very brittle, and it's almost not recoverable at all. Drying filament right is the single highest leverage thing that you can do to improve your print quality. It costs you almost nothing, and it just takes discipline. And that's the difference between aerospace grade parts and a scrap bin full of expensive polymers. Now, we help engineering teams figure this out every single day. The right materials, the right processes, the right machines. From our own 22 IDEX to the Aeon Hilo for the huge flight certified parts. Head over to visionminer.com, check out the full material lineup at visionminer.com/materials. Ultem, PEEK, carbon fiber nylons, many different grades of nylon. You name it, we've got it. We can also provide COAs and COCs for virtually every spool we sell because most of our customers are industrial, especially in aerospace or medical. So if you're qualifying parts for aerospace or medical devices, the traceability is there when you buy it from us. So give us a call, shoot us an email, check out the website. You can talk to somebody real right here in America, and this is what we've been doing for the past decade. Anyway, thank you so much for watching. Have a positive rest of your day, and I'll see you on the next one.